Okay, so we are looking at unit 2 in QM, which is a quantitative method, organization, presentation of data. Very, very important topic in quantitative method. And of course, we'll build up a little bit looking at the other components to do with the Chebyshev rule, the outliers, and the empirical rule. Okay, so this is almost just like about the first question in an exam that everyone else needs to understand. Very, very important. All right, so now we get to the method of organizing and presenting of data. Okay, so here we look at a number of things where we look at the frequency, the histogram. Okay, we have a number of things that we look at on this one. So we have, first and foremost, we look at the graphical presentation of data, which is on the histogram. We also look at the bar chart, the pie chart. So we have the histogram there, the frequency distribution. And then we also look at the data, if it is ungrouped data or if it's a grouped data. Okay, so this is about the cardinal point that needs to be understood on this one. Then we also look at the constructing the frequency polygon, the histogram, like I mentioned. All right, so this is just what we are going to look at about now. All right, so from here, you can have an example where we have this example. We are working for the transport manager of a large chain of supermarkets. Then we have been given the values that are there from 138 to 120. The numbers are mumbo jumbled there, but we are supposed to present this data accordingly. So we should have the minimum value, the maximum value, and we can go for the range. Okay, so we can go for the range where we have the values that are here. We have the ranges depending on what we have for this data set. So we look at the maximum, the minimum number is 105, the maximum is 186. The range is the difference between the minimum and the maximum value. This is about how we get the range. So range is simply the difference between the highest measure and the lowest measure in the data set. Okay, so from here, we can look at the minimum possible amount. So they're saying, from this example, from this question, they're simply saying, you are working for the transport manager of a large chain of supermarkets which hires cars for the use of its staff. Your boss is interested in the weekly distances covered by these cars. Mileages recorded for a sample of hired vehicles from fleet 1 during the week. You did the following data. So we have that one. So we can find the minimum value, maximum value, and the range. From there, we can present this data in form of a frequency distribution where we have the class interval. So here, okay, 9 intervals of 10 miles, with this seems reasonable, but extremes. So we have 10, but under 110, 110, but under 120. So 120, but under 130. So we have the tally. We can find how many they are. So here we can just count how many are between 100 and less 110. We can count from the data set that we have been given 1, 2, 3, 4. Okay, so 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where the 10 is coming from. Somebody would ask, why are we starting from 100? Okay, we know the minimum value here is 105. So 105, we know it's between, so we can start from 100. So you say 105 is in between 100 and 110. So this is where we picked up 100 because we looked at the minimum value here is 105. And then we have how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where the 10 is coming from. So 100 and under 110, that's where the 10 is coming from. All right, then getting down up to the 190 there. So we can now see how we are going to be counting to find the tally values. All right, so this is about what this one is going on. So we can actually find the frequency. The frequency is giving us 40 when we add these. All right, of course, we can get into the tally and the frequencies that we have there. Okay, so the histogram can be drawn. We are saying 100 and under 110, we can draw the histogram there. But before getting down to the histogram, we can now present the data in terms of the frequency distribution. Okay, so in terms of frequency distribution, we can present the data. Okay, so in terms of frequency distribution, we are now trying to get the data. Okay, so we can present the data in terms of the frequency distribution. So we are now saying our interval is 100, the frequencies are these. So the cumulative frequency, we start adding from there as we look at the value that we have there on the frequency distribution. Now, what we're supposed to now get down to is how we present the histogram. So histogram, we can see from the first one, we are simply saying from here, we have 100 and one under one, less 110. Okay, so we can go from this is the frequency, so the mileage and the frequency here. Okay, so histogram will be drawn without the spaces in between. So 100 and 110 was supposed to be 4. All right, so we are getting these figures there that are supposed to be there. Then the other one is 140 and 150. 140 and 150 here, it is 11. So 11 is on this point. Then we get to the other one, the 100 and less 110, 100 and less 110, it was supposed to be 4. 100 and less 110, it was supposed to be 4. So here it was supposed to be a 4 there. Then we have 110 and 120, there was nothing. So it's nothing here. All right, then getting down to 120 and the 130, 120, 130, there are 3, it's 3. So that's a 3 here on the histogram. Please take note of how the histogram is obtained. So here, just a 3 there. So this is putting 130 here at this point. So a histogram is drawn in such a way that it has no spaces in between. If you have any space, like here for the one between 110 and 120, it's a new, so it's a new there. Then the first one is 4, the other one is 3, the other one is 7. 130, getting down to 130 to 140, we are getting 7, so it's 7 there. 137, which is this one here at this point, it is what we have. Getting down to 140 to 150, we can put what we have there in the frequency between 140 and 150. So 140 and 150, we can check 140 and 150, it's 11. So 140 and 150 is 11. So it's this one at this point. So this is how the histogram is obtained. So this other one, we have that other point, it's ending at that point there. This one is ending at that point there. The other one is ending at that point. So meaning these are 1, 1 from 170 to okay, so we have that one there. We're getting down that amount there. Okay, so this is on what we are getting there on this kind of. So the frequency density, we can add these two, divide by 2, we are getting that amount. Okay, so here is these two, divide by 2, you're getting a 2, which is a midpoint frequency density. Okay, so the other one, 4 and 0, the average of these two, it is a 2. So that is coming as a midpoint. This 0 and 3, for I know somebody may want to find out. Okay, then we have this one is nothing, so we get it at 1. So 7, 11 is just alone there. Then here we have 8, 5. Here, when you have a 0, you find the average. 4 and 0 here, 4 and 0, there's a 0 here. So average of these, the frequency for these two, the average is 2. But when it's just 1, a 3 is just alone, so let it be. A 7 is just alone, let it be. A 11 is just alone, let it be. 8 is alone, let it be. 5 is alone, let it be. Now here, 0 and 2, okay, you can find the average of this, which is giving us a 1. So this one giving us the average of these two, a 2. But here, since there's a 0 here, that's why we have gotten a 2. But these other numbers, there is no other 0 in the midst for these ones. So just take them the way they are, divide by 1, 3 by 1, 3, 7 by 1, divide by 1, you're getting that one. That's how you're getting the frequency density on the other part of it. Because this is what is going on. So the histogram is presented without spaces in between. For these other ones, 0 and 4, you can find the average of this and its midpoint there. But a 3 is alone, let it be. And then 7 is alone, let it be. 8, 11 is alone, let it be. And then this other one is alone, let it be. But these ones, there's a 0, find the midpoint. All right, so the histogram.
How you choose it? How are you determining that this is alone?
Okay, so what we are saying is this: the 0 is empty here. There's nothing here on the tally amount that we have here. On the tally amount, we don't have any value here. Okay, and then the other one here, there's a dash, also meaning that it's a 0. So it's alone here, so meaning it's empty. It's empty. So we need to find the average for the empty values to get the midpoint. But this one and this other one on top there, it was empty. So we had to find this on top and this other one to find the average where you are getting it to. So it's average. But this other one, there's no other zeros. So you take them the way they are in short. All right, so.
So if it's alone, you take it as it is.
Yes.
Where there are zeros, you average with the next.
Yes, that's the way it's supposed to be. You average, okay. You average with the next, yes. All right, so yeah.
Now, if it was if the zeros.
Yes, please.
On the frequency.
On the frequency, yes, on the frequency, there's a question there.
Yeah, if there was 4 and where there's 0, there was 2, you can still average the 2, or you leave them like that.
Just leave them like that. If there were no zeros, we would have left them like the other ones, the way they are.
Okay.
All right, so is it clear on the histogram? The histogram, how it has been plotted?
No, just. Hello?
Yes, please.
Can you? Yes. So
yeah.
You say that
with the 0, because the 0 will be averaged with the next. The next is 3. That's on the first line. Then at the bottom here, where we have 0,
The next one is 2. So 0 average with 2, that makes sense. Now, on the first one, why are we averaging 0 with 4 instead of 3?
Okay, the rationale here is this. This one on the second one, it's empty. Okay, it's empty, meaning that here we wouldn't have had anything here. Now, what is happening is, since we have a 0 here, we cannot take a 4 straight away there. We average with the up there. So these 2 and these 2 at the bottom. This is how we do it. So these 2 up and the 2 down, they're supposed to be averaged if it are zeros. The 2 up there and the 2 down, they're supposed to be averaged to find the midpoint.
Okay, so now let's do this. If the 0 was, let's say, where 8 is, are we going to average the 0 with 5 or with 11?
With 11.
So now if we're averaging the 0 with what is on top, why are we averaging 0 at the bottom with 2 instead of 5?
Okay, what happens is that here, there is nothing here. So meaning what is going to happen is there's a last number here, which we should go with this one. So even this one, we just get a 2 up there and a 2 up there. If the 0 was here, we would have gotten an 11 and a 0, because meaning that up there is a starting number. So this one is the, okay, so let's see the starting number and this one. So meaning this is a starting number and this one. So a 4 is a starting number and a 0. So this is a starting number and this other one. So that's why we are getting these. So meaning you get up, the one which is up and the one which is down to average.
Okay.
All right. So this is only the frequency density. I'm sure you just have time to go through that again. Then we have the histogram. The histogram, I think I'm sure everyone else has understood where these figures are coming from. The diagram. Is it okay? For the histogram, we are using the interval and the frequencies. The interval and the frequencies to get to plot the histogram, which has no spaces in between. Because 100 and 110, then where 110 is beginning, that's where we're 120. So we are getting these values here. So between 110 and 120, we don't have any value. The frequency is 0. So this is where you have the 0 frequency here. Okay. So we are getting 0 frequency. And then the other one, we are getting those other values. So this is about the histogram. All right. Unless there are questions so far, before we move on to the other.
Go back to the frequency distribution table.
Okay, which is this one, the 4, 0, 3, 7, 11, 8, 5, 0, and 2.
Okay, so we're using the frequency to plot the histogram.
Yes, well, every time we use the frequency to plot the histogram. Every time against the intervals. So we use the frequencies to plot the histogram. So we put the interval here. So meaning this is 100. But of course here you can just say, okay, pardon me. In an exam to say, pardon me, because this cannot be from here to here, it cannot be 100. So you just cut here to say, of course, we can have a length away from 0. But pardon me, you cut these, then you start from 100 to 110. It's 4. So that's where you go up to 4 there. Then from 110 to 120, it's 0. So you put a 0 there. Then getting down to 120 to 130, you put is a 3 there. Then just about you're finishing up just like that to plot. And then the other one, we are getting a 0, which is from which one? The 170 to 180, 170 to 180. So here there was nothing. It was supposed to be just is the dash. So this one, ignore about it. It was supposed to be empty, same as this other one here. On the 110 to 120, 110 to 120, there was 0. So it was supposed to be just at the bottom here. There's nothing. Even here, it's supposed to be just at the bottom. So ignore about this. It is only the other one, which is getting up to 2. So the other one is getting up to 2, 180 to 190. It's getting up to 2. So it's getting from here up to here. All right. So this is how this histogram would have been actually plotted. So the histogram would have actually come through this way. All right. So this is on the histogram aspect. Okay. So where it's empty, please leave it on dry. It's a 0. All right. So it's a 0 there. Then the other one is also empty here. So your histogram can come through that this way. So you consider this one where it's ending on a 2 using the frequency. So here is a mileage, and then here you put F, which is for presenting the frequency. So frequency against mileage. All right. So meaning without mileage, there cannot be any frequency. So you're looking at kilometer allowance is actually independent. That's why it's on the horizontal line, because you can only determine the kilometer allowance of frequency of times that you go to a certain center or a certain place or a certain venue. So how many times, that's the frequency. So the mileage is independent. If you don't want, you cannot go there. So this is about what this one is on. All right. So we can now get in down. So from here, we have done the histogram. Then we can get into the frequency polygon. So histogram is given by this one. Now here we can know the histogram should not have any spaces in between. Just that here we are the 0 frequency. That's why it is here at this point. Okay, if it had the 1, would have plotted up to 1. If it had a 4, would have 5 or 6 or 8, would have gone for it. In a similar way, we would have done the other ones. So would have followed accordingly. All right, so we are using the frequency against that. Anyway, so we now move on to this is the frequency polygon. Okay, so here frequency polygon, we are now getting the frequency polygon where we are just getting the frequencies and accumulating it to that one. So at here between 100, the frequency was 0. So we are now having the frequency, cumulative frequency here, cumulative frequency diagram. So we are getting these ones. So 0, 100 here and 0. Then 120 getting down to 4. You can estimate that. Then 130 getting down to 7. You can just estimate that. So this is an estimation of how the graph came in. And then, of course, if you're using the percentages, we are saying the first one is 100, using the percentages, frequency diagram using the percentages. So meaning we are going to say 100 is at this point. Then 120 and 10 is at this point. Then 140 and 17, that is 130 and 17.5. So it's 130 and 17.5 somewhere. Then 140 and 35 is somewhere there. And then just about that, then 190 getting down to 100. So here to 100. So here, this is the cumulative frequency diagram. The cumulative frequency diagram using the percentage of the cumulative frequencies. All right, so this is about how we are getting these ones. All right, so we can get to an example where we are looking at okay, we can get down to this example here based on an empirical rule. I want me to explain the empirical rule now, the empirical rule method, which the examiner would actually go for in an exam, which is a cardinal one that you really need to know how to do the empirical rule, okay, for anything else. So we're combining the descriptive statistics and empirical rule. of course, I will get an extra mile to explain the Chebyshev rule. Okay, so where we look at what rule applies to the Chebyshev. So we can do two of them. I know the other ones, we're getting down the mean, the variance, the standard deviations, all those, that is not as cumbersome as possible. So now let's look at the empirical rule. So the number, this question came in one of the test papers, that is getting down to, okay, so getting down to September 25th, September, okay, 2022, where we are looking at this question. It was a second question 1, but B, where they're saying the number of customers attended by a cashier in a pharmacy, okay, in the same hour-long period is normally distributed with the mean of 31.6 and a standard deviation of 7.5. Identify the range of values around the mean that includes 95% of customers. That include 95% of customers. All right. So here we have this kind of program where we are saying 95% of customers, indirectly, they are simply telling us that we have the mu, which is the mean of Z1.6, the standard deviation is 7.5. Now, as per empirical rule, even if they didn't mention in an exam, we're supposed to use the empirical rule. So as per empirical rule, 95% of data falls within 2 standard deviations of the mean. So it falls within the 2 standard deviations of the mean. We have a shape like this one, where we know that here we have -2, okay, the standard deviation of the mean. Even here, we have a +2. Of course, the range of values, the standard amount for the Z value for normal distribution is up to 3. So the percent of values, meaning that they have given us this percent, where they are saying this percent is 95%. All right. So meaning what we are going to do now here, we are going to seek to determine what value. Okay. So they're saying identify the range of values that fall around the mean, that includes 95%. All right. So 95%, we are simply talking about 2 standard deviations of the mean. All right, because when we go to the Z table, this probability here is 0.4772. If you can check from the normal tables, the way they are, even this other one is 0.4772. Okay, so we can now multiply the 0.4772 for the entire 0.4772 times 2, it's about 95.44. So when you add these two, it's about 95.44%, which is the equivalent to the 95% which was given in that question there. Okay, so this is now from here. What goes on is we can get the lower range. Okay, so the interval is positive. The mu should be plus or minus to the standard deviation. Okay, so our interval we should have here, which is positive or negative of that value. Okay, so for an interval, we are saying we are getting the mu positive or negative to standard deviation. Okay, to standard deviation. So from this interval here, we know from the question that our mean has been given 31.6. So our mu is equal to 31.6. Okay, so mu is 31.6, please. Then our standard deviation has been given. We can see our standard deviation there is 7.5. So standard deviation is 7.5. So we want to find the range of values that fall within that. So meaning identify a range of values around the mean that includes 95% of customers. So we know that it's within the 2 standard deviation of the mean for us to get this, because the -2 from the table, the normal tables, we get 0.4. So from this area, the entire area here is 0.95 or 95.44. All right, so now we can now find the lower bound. So we are going to say lower range. Okay, so our lower range is equal to, okay, we are going to say it's a mu, okay, then minus the 2 and then the standard deviation. So meaning our mu we know, all right, so meaning we can put that figure there, 31.6. So I have the 31.6, okay, then the standard deviation is 7.5. Okay, so now getting down to this one, our lower range, let's find our lower range. Okay, so lower range, we are going to get the amount where we are saying is equal to mu minus the 2 standard deviation. What's our mu? Our mu have been given. You can give me the value of the mu. Mu is what? 31 point what?
6.
31.6, yes. The standard deviation is giving us 7.5. Okay, so 7.5 is the standard deviation. So you can substitute here and get the range. You want to find the range. So here the mu is 31.6 minus the 2. It was obtained because of 95%, which we can get from the normal tables. All right. Then on the standard deviation is 7.5. Okay, so meaning you can find that we are getting 31.6 then minus 15. Okay, so it's giving us 16.6 here on the lower range. So it's getting 16.6. That is on the lower range. Now, getting down to the upper range, it's just the opposite of the lower range, where we are getting our mu is 31.6, then plus then 2 on 7.5. Okay, so meaning that we are getting our value there will be 15 plus 31.6, which is giving us 46.6. 46.6. All right. So this is about what we have. So meaning our range here will be, so our interval, or they just say our interval here that they are looking for is actually going to be equal to, all right, 16.6. Okay, so it's 16.6 less or equal to x, and then less or equal to 46.6. So this is how you find when they say within the 3 standard deviation of the mean, to find the interval. When you have found the mean and the standard deviation, you just substitute to find the lower bound and then to find the upper bound. When you have found the mean and they say within the 2 standard deviations of the mean, we substitute here to get. So this is the range or the interval that is supposed to be there. Is there any question so far? Excuse me, is there any question so far? On now we are getting the interval here, that is 16.6 less or equal to x less or equal to 46.6. Is there any interval? Is there a question?
On the upper range,
Yes.
what the formula is also mu minus ZQ.
No, the formula is mu plus, so here is opposite, mu plus the 2 sigma. So it's opposite to the first one. So this one is a minus for the lower range, is minus. For the upper range is a plus. So that is the distinction between the two. Is that clear? All right. Have I answered your question?
Yes, sir.
Yeah. So the other one you use a plus, the other one you use a minus. So this is how you find the interval. When they say within the two, sometimes they will specify to say within the 2 standard deviations of the mean. So within the 2, the interval is mu positive or negative 2 standard deviation. So when they say within 2 standard deviation, you use this interval. When they say within the 3 standard deviation of the mean, you use this interval, positive or negative 3 standard deviation. Okay, so it's within 3. So there's only within 1, within 2, and within 3. So meaning within 1, it will be mu positive or negative, but you simply say within 1. So meaning 1 standard, don't put the 1 there, just let it be like this. So within 1 standard deviation of the mean. So the other one is within 3 standard deviation of the mean. Then the other one is within 2 standard deviations of the mean. All right. So this is about how you find the range or interval. So you can find the lower bound or lower range by simply using the formula and substituting in that equation. Then you are able to get the value that you need, please. All right.
And the interval. On the interval, do you leave it just like that, or you need to like continue calculating?
So the interval, we are saying that the values, all the values should fall within this interval, 16.6 to 46.6. So you can find this, you can even check if there is any outlier by looking at the data set. All the figures that you have, they fall within this interval, then there is no outlier. You know what I mean? An example, you can be in a class where we find that all of you are in the same age group. Maybe the maximum age somebody has is 50 years or maybe 60 years, but you can find somebody doing his master's at 100 years or 85 years. Then that person may be considered as an outlier. So you may find it doesn't fall within that group. You know what I mean? So this is the range that we use. So we can find the percentage of values that are within this range. So meaning that 95% of values are within the range of 16.6 to 46.6. That's an interpretation. Are we together? Is that clear?
Yes.
Okay. So this is only the empirical rule, where we're looking at the empirical rule. Okay. I know in the other class we are supposed to do the Chebyshev. They just advise me if we can continue. I explain the Chebyshev, or maybe you have class up to this time that maybe you can do that one in the next class. I don't know how you can advise me, because this is almost 14 hours now. I don't know how much time was allocated for you for this class.
Normally, lunch hour classes are about 1 hour.
So we're supposed
So
to
it's only
end.
that.
So what time can we end? Can we end now, or is it about 14 hours, or what are we suggesting?
It's 14:20 somewhere there.
Okay, so let me explain to you the Chebyshev rule. So I've explained the empirical rule. So empirical rule can be within one standard deviation of the mean, within the two standard deviations of the mean, and then within the three standard deviations of the mean. So there are only three components. So to find the lower range, if you are using within one standard deviation of the mean, to be just mu minus standard deviation, then you find the lower range, meaning that these two will not be there for within one standard deviation. Within a two should be there. Within a three should be there and multiplied by standard deviation, so that you find the range for the lower bound and the upper bound. Okay, so
Just repeat that. Just repeat that, please.
go on, what I say?
I said, just repeat what you just said.
Okay, so what I'm trying to say is, in an exam, they would specify that you need to do within the two standard deviations of the mean, meaning to find the lower range, you get the mu, which is this mean here. If it's within a three, you put, for the lower bound, just put quite right a minus here, but it's a 3 multiplied by the standard deviation, which will be given in the question to find the lower bound. When they say within 3, so you use the 3 as a constant number. If they say within one standard deviation of the mean, it will just be mu minus the standard deviation, which will be a single one. Then you can substitute and get the value. All right. Within a 2, so that the one you are doing here, the one we answered, this is the interval within the two standard deviations of the mean. Okay. Is that clear?
Yes, thank you.
Okay, so now let us get into Chebyshev. Okay, so let's get into what we call Chebyshev. Okay, so Chebyshev.
Sorry, Mr.
This is Mr. Stan.
Yes, Mr. Stan.
You can go Mr. Stan or Mr.
I
Mule.
think-
No worries, whichever way, Mr.
Okay.
Mule or Mr. Stan. Yes, please.
Mr. Stan, I think I keep on logging in and out. So now on the differences between within 3, within 2, I think I missed that part.
Okay, here we are simply saying within 3 standard deviation of the mean, meaning that where there is a 2 here, you put a 3, but to get the lower range, you put what the mean value that you've been given there minus 3 on the standard deviation. You get the point, right?
So the
what-
question was actually,
Yes.
the question will specify that you calculate using within 3.
But now I have to make mention to you. These are standardized. When they give you 95% in an exam, meaning that it's within 2 standard deviations. Okay. When they give you 68%, it's within 1. I'm just trying to give you now a guide. So it's within 1. Then if they give you 97, okay, 99.7 or 97%, anything above this, anything above 95%, 97%, so to speak, 97.7 is within the 3. So if they mention in an exam that is with 95%, like the way it was, is it within 2 standard deviation. These are standardized values. Okay, but we can still get them in the normal tables, but usually there are only 3 ways. There's within 1, within 2, and within 3. There's no other way that the examiner would ask you. So it's just within 1, within 2, and within 3. That is the normal way it's supposed to be, because the normal distribution, the maximum possible value is a standard value, which is a 3. You get the point?
Is there a question you can show us which has that within something in it?
Yeah, yes, the same paper where we are actually doing this, the same paper where we're looking at, it had okay, so this same paper where this question came from. This question came from, if you go for this test paper, check for this test paper here, where we can, in the next class, we can go for those. All of them came as within 1, within 2, and within 3. The one which was dated 25th September 2020. There's this one, I'm sure you're able to see it, the UNLAS, where we are.
As we are not, some of us are not at UNLAS, so we may not be.
Okay, no worries, no worries, but we are getting it.
Maybe if you can just scroll down to the same question, so to just have an idea of how it is within the term about.
Okay, unfortunately, whatever was captured was it wasn't the full set of the question paper. So the full set of the question paper will be sent to you anytime soon. So we need to come and get deeper in within 1, within 2, within 3. But just that the first page was captured, the other document was not captured. So like what I've explained now, it was within 2. So meaning we need to come and explain to you how you get it within within 1. Okay, so within 1, within 2, and within 3. Okay, so that is what we are going to actually look at. So this is within 2. So for now, just so like the concept here, when they say within 3, we only substitute where there is a 2. Like here, it was within 2. So because 95% was falling within that. Okay, like I mentioned. So because we said on this one, there is this shape here where within 2, meaning that here is 0.4772, 0.47. So when you add these, the entire area here is giving us the 95.44%. So within 2, so it's approximately 95%, because we can't round up to 96, 95.44. So the 0.4472, using the standard normal tables, we are getting this. Okay, so identify the range of values around the mean. So around the mean range, find the range of values around the mean. That includes 95% of customers. So we are looking at the within 2 standard deviation of the mean. So 95% will be given in an exam, meaning that within 2. And then we have the other one. They mentioned, like I gave the standardized, because they're only within 1, within 2, and within 3. So meaning this is where the 2 came from, as we looked at this one. So within 2, and then the mean was given. So just a matter to find the lower range, to just substitute the mean, the 1.6, the 2, we computed it from there. 95% is within 2, the 68% within 1, 97% within 3. These are standardized. There's nothing more that examiner would ask. They are just standardized within 1, within 2, within 3, because the maximum possible bell shape for normal distribution, for the bell shape, is within this one. So it's -3 to +3. These are the ranges of Z values for normal distribution. Is within, so there's within 1, within 2, and within 3. So that's why the 3 come from. So there's -3 to +3. Then you have also -2 to +2. Then you have also -1 to +1. So this is the standardized values that are there. All right. I'm sure I've answered your question.
Yes, you have.
Yeah, so now lower range, you can put mu, that 1.6 minus 2 is a standardized number within 2. So you can substitute there to get the lower range. Then getting down to the upper range, you can substitute there to get, so this is the interval. So if you do the same when this number changes, the mean can be the same. So in an exam, they can only change the percentage when they say within 68%. So you just ignore a 2. So you go for within 1. So meaning the lower range will actually be equal to mu minus the standard deviation to get the lower range. The upper range will be equal to mu minus, this is mu plus the standard deviation. So this is within 1. So you can use this one and substitute and find the interval that will be there. All right. So even for the 3, within 3, it's just the same concept. What will change is the number. So it will be -3 here, but the concept is what is very, very important. Okay. So this is one empirical rule where we have the 1 standard deviation, 2, and the 3. All right. So now let me explain the other one, which is the Chebyshev rule. Okay. So the Chebyshev rule uses, so let's go to the Chebyshev. Okay, so we can go for Chebyshev. So this is another one, which is very, very important. So Chebyshev. So Chebyshev rule. Okay, so under the Chebyshev rule, we have the formula here, percentage. We have here, for getting n percentage, there is a formula we use for Chebyshev. So our percentage is given by, okay, so we have our percentage is actually given by 1 minus 1 over k squared. So this is only the Chebyshev rule, please, and where k is constant. So where our k is a constant number, it can be 2, okay, it's not negative, so this one is constant, okay. So this is about what we go for, okay. So this is what goes on here, okay. Now for this one, the interval is also the same. So the interval is also the same. So our interval for Chebyshev is actually going to be, so we have is mu positive or negative, then k on the standard deviation. So this is our interval where k is constant. All right. So the mu can be given. Okay. I'm sure everyone else is please, if you're behind it, tell me, I explain. So this is how I find the percentage. All right. So you can be given mu of an example, mu of 20. Then the standard deviation of 5. And then they say the percentage for this range is 97.5. Okay, they are giving us the percentage. And then they'll ask us for the interval. All right. So on the Chebyshev rule, please pay attention to details. So this is on 97.5%. That is it, the percentage they've given us. So who can help us to get our K? Because here, this is the formula for the Chebyshev rule. So in an exam, they will give you, so what is important here? Understand the concept. Mean is 20, standard deviation is 5. Then they will ask us to find the percentage of intervals. Okay, that for within they will find what is the interval that will give us the percentage of 97.5. Determine the interval to give us 97.5 using Chebyshev rule. All right. So meaning we can use this formula first to find our K. When we find our K, then we can find the interval. Okay, so meaning what is 97.5? 97.5 is what? Divided by 100 is giving us what? 0.975. So it meaning the 0.975, we are using that formula there, is actually equal to what? 1 minus 1 over k to the power 2, k squared. That's the formula there. Are we together?
Yes.
Yes.
Please follow through on this Chebyshev formula, please, please. Then after this, we're going to find the interval now. So they will say using Chebyshev rule, determine the interval that will give us 97.5%. So this is how we are getting the percentage there. 1 minus, this is the constant. So let us find our K. When we find our K, then we come and find the interval. So meaning, what are we going to get? We take this one the other side. So it will be 1 over k square, all right, which is equal to 1 minus the 0.975. Okay, now this one is also over, just simply say over 1. So we are simply saying 1 over K square is actually equal to, let's subtract here. 1 minus answer, what are we getting? The 0 point what? 0 point, give me the answer there. We have calculated 0 0.0 what? 0 0.0 what? 0.025, not so.
Yes.
So it's like here the rationale behind is for us to find our K first and foremost. So 0.025, you divide by, it's more like you're dividing by 1. So cross multiply. So meaning it will give us, see, as we cross multiply, it will be 1. So here, let me put a comma. To be 1 is equal to the 0.025 and the K square. All right. So what are we doing? You divide by the 0 point what? 0.025. Are we together? So 0.025, even here by what? 0.025. I will not cruise. I want people to understand. So what are we getting here? What is our, so here I can take it up here this side. Our K square will give us what? So it's K square is equal to what? Calculate for me.
40. It's 40.
Okay, it's equal to what?
40.
40. Of course, just that we have gotten that one. Okay. We have gotten that one. Okay, so we can now find the square root of this. So our square root of this is what? So what is important now? Let's find the square root so that we find our K. But sometimes we find that the examiner will give you, this one would have given us the exact answer in sometimes. You know what I mean? Are we together? So the square root of 40, 6.32. So 6.3 what? 32. That is our K. Are we together? But you know, in other books, in other questions, the examiner will give you a percentage whereby as you find your K, it will give you, as you find your K, it will give you the exact amount. You've seen that, huh? So another time we find that the examiner will give you a question where as you find your K here, we find that it has given you the exact amount, which is like an example, which will give us maybe 4 or a constant 6. So meaning you can manipulate this percentage so that it gives you the constant, like the whole number. You know what I mean? Eh?
Just tell me I'm lost.
Okay, where are you behind?
Just how from the, just how in the 1 over K squared is equal to 1 minus 0.975 over 1.
Okay, but have you seen this star here for the formula for Chebyshev? Percentage is equal to 1 minus 1 over K square.
Yes, I've seen that.
So now an examiner will give you the percentage to say, find the interval that will give us the percentage of 97.5%. So meaning where there's a percentage here, we substituted. So here, this is where this one came from. You've seen that, huh?
Okay.
Then 0.975. Okay, 97.5 divided by 100. 97.5 divided by 100. We are getting what? 0.975. You've seen it, huh?
Yes.
Then this other side, this formula is still hot, which is the same formula which I'm using here for the percentage. That's what we are using to find the value of K. The K is not given.
Okay.
All right. Are we together there?
Okay. Yes.
Yeah, so we are now trying to sort out the value of K. So this is where we said now, this one, since it has a minus sign, this one, take all of it to the other side, it becomes a plus. When this one crosses the equal sign, when it comes this other side here, you've seen?
Yes.
Have you seen? So it becomes 1 over K square, not so?
Yes.
Which is equal to 1 minus, this other side going the other side to be minus now. Because to be, it's minus. You are now clear there?
Yes.
So after that, we're subtracting, we got 1 over k square, which is here now, the second component, which is where here, look at this, which is it 1 over k squared is equal to 0.025 over 1, same as over 1. Is that okay? Okay. I'm
So
sure.
now, why were we putting over 1 on the other side?
Okay, so meaning when you have 200 kwacha divided by 1, it will still give you a 200 kwacha. Yeah, so it will still give you a 200 kwacha. So meaning that's why even if we divide this one by 1, it will still give us a 0.025. It will still give us that, it won't change. Any number divided by 1, it will still give you that number. It will still a constant. You've seen that time?
Okay.
All right. So this is about it, how this one came in. So on the Chebyshev, we got our K. Okay. So on the K, so that's how we found now. Here we said now, from this end, after cross multiplying, we simply said, okay, with this one, so meaning that after cross multiplying, yes, so we got here K on this other side, so it will be 0.025 K, which is equal to 1. Okay, when you cross multiplying here, you've seen that, huh? So this one multiplied by the 0.025, it will be 0.025 K square, and then 1 times 1, 1. So it will give us the 0.025 then K square, which is equal to 1. Now here we are trying to find the K, so divide by the 0.025. Even the other side, we divide by the 0.025. Okay, so we are getting our K is actually equal to, K is equal to 1 divided by 0.025, which is going to 40. So K is equal to, K square is equal to 40. So our K square here is equal to 40. So we can now divide. This is just about the concept, what is important. In other books, you find that this one would have given us maybe 49. So our K, we will find the square root of this. Okay, so meaning our K here, the square root of 40, we found it, the square root of 40 gave us 6.32. Okay, so 6.32. This is it on our K. Now, here the interval for Chebyshev is given by mu, positive or negative, K, and the standard deviation. So where K is constant. So we have that one. So the mu was given. If you check, the mu was what? 20. Standard deviation was 5. So mu is equal to 20. And then the standard deviation is actually equal to 5. But we found, using this percentage, we found our K. So we can now substitute our K. That's why the examiner gave us a percentage here so that we can use it to find the K. So after finding the K, then we can substitute here to find the lower range or lower bound. So lower range. Okay, so lower range is going to give us the, okay, we are going to get the mu minus K and the standard deviation. So which means it will be 20 minus our K, you can get the 6.32, then multiply by 5. Okay, multiply by 5, so you can find our lower range. Even if it gives us a minus, doesn't matter. So 20 minus 6.32, okay, times 5.
31.62.
It's giving us what?
31.62 minus 20, which is negative 11.62.
Negative 11.66. Okay, that's somewhere here. Then let's find the upper range. So this is the interval now. That's the range of values. So upper range. Okay. So here, what is important for you to understand the concept as we look at the Chebyshev. So this other one will give us mu then plus K standard deviation. So this is K is constant on the interval. So the K is not given for Chebyshev, okay? But for empirical rule, where there is K can be within the two standard deviation of the mean as it were. So we can now say 20, okay? Then plus our K is 6.32, okay? Then multiply by the standard deviation, which is 5, okay? So we can now get. So this was just an assumption that standard deviation is 5. But of course, we find the examiner, if he never wanted the range to be negative, the standard deviation would have been 1 or it would have been 1.5. So that as we multiplied that, it would have been a lower range, would have given us the positive figure as well. So there, 6.32 times 5, then plus 20. So we are getting 51.6. Okay, so 51.6. So the range is going to be now for the using the Chebyshev is going to be negative 11.6, then less or equal to x. That's an interval. Then less or equal to 51.6. All right, 51.6. So the other one for empirical rule we did in that paper for the part timing. So this is about how you go for the Chebyshev rule using the mean and the standard deviation and the formula that has been given there. I think you've seen it, that. And then for the empirical rule, we have these other ones where we look at within one standard deviation of the mean, where we got this came from the test paper that we looked at, where we have found for empirical rule 16.6 less or equal to x less or equal to 46.6. And this came from the test paper. Okay, so the test paper that was done part timings in University of Osaka 25th. So we did this one for empirical rule where we found the range which was given by that. All right. So unless there are any other questions, but okay, so we have gotten down to these ones. So you just need to go through so we can end the class for now.
Hi.